Okay, so let's finish talking about the test review. So this is the second page here, number 6. A particle moves along a straight line according to the given equation. So here's our position function, and this is where t is greater than or equal to 0. Okay, so we want to find out for part A, when is a particle moving to the left? So we know that to determine when the particle is moving to the left, we need to look at its velocity function. And when we look at its velocity function, we need to first determine when where the critical points are, where the velocity is equal to 0. So we're going to take our velocity function and we're going to set it equal to 0 and go from there. So to find the velocity function, we take our position function, we find the derivative, so we go through power rule for each term, bring down the 3. So 2/3 times 3t squared minus 4t minus 0. So here's our velocity function. And from our velocity function, we can set that equal to 0 to find its critical value, to find when the velocity is 0. So then set velocity equal to 0, factor out the 2t, and then we're going to get t is equal to 0 and 2. So the velocity will be 0 at 0 and 2, so we put those values on the sign line. 0 is also the endpoint for our domain. And then we just have to test the interval. If we get a negative value, that means this particle is moving to the left. If we get a positive value, that means this object is moving to the right. Okay, so then we choose a value in between this interval, 1. So if I plug 1 in, I'm going to get a negative value. So from 0 to 2 will be negative. If I plug in 3, I'll get 6 times 1. So that will give me a positive value. So I know that velocity will be positive here. So this portion, this object is moving to the left. This portion, object moving to the right. So when is the particle moving to the left? We read our sign line and we know that's going to be from 0 to 2. Okay, part B. Find when the velocity is increasing. So when we see this word, velocity is increasing, this is referring to the rate of change of velocity. And rate of change of velocity is acceleration. So in other words, this is asking, when is acceleration positive? So to find out when acceleration is positive, we want to find, create a sign line for acceleration, and then plot its critical value and test each interval. So acceleration is simply the derivative of velocity. So 2t squared becomes 4t, 4t becomes 4. We set our acceleration function equal to 0 to find the critical value, to find out when acceleration is 0. So we can put it onto the sign line. So 4t minus 4 is equal to 0. Factor out the 4. T minus 1 is equal to 0. So t is equal to 1. So starting point is 0. Critical point is at 1. We have to test each value, so I can plug 1/2 into the acceleration function. So 1/2 minus 1 is negative, so negative acceleration in this interval. If I plug in 2, 2 minus 1 is positive, so I'll get a positive acceleration in this interval. Okay, so now we know acceleration is going to be positive, or in other words, velocity is increasing in this interval from 1 to infinity. Okay, part C. Find out when the speed is decreasing. So speed is decreasing means that we have to compare signs between velocity and acceleration. If they both have same signs, that means speed is increasing. If they both have opposite signs, we know that speed is going to be decreasing. So we have to find out the range of values where there's going to be opposite signs. So let's look at the velocity sign line and the acceleration sign line, see if we can put this information onto the same sign line so we can easily compare the signs. Right. So I'm going to put the velocity signs up top, the acceleration at the bottom, and I'll put both 1 and 2 because they're critical points for their respective functions onto the sign line. So velocity is negative from 0 to 2, so I'll put negative from 0 to 1, negative from 1 to 2, and then positive to the right of 2. Okay, acceleration will be negative from 0 to 1, and then to the right of 1 we have positive, positive. So now let's compare the signs. Between 0 and 1, we have same signs, so speed is going to be increasing here. Between 2 to infinity, positive, positive, same signs between velocity and acceleration. So we know that there's going to be speed is increasing. So between 1 and 2, this is going to be where we have opposite signs. So opposite signs indicate decreasing speed. So our interval will be from 1 to 2. Okay, part D, where's the particle located when the velocity is 0? So we need to first find out when the velocity is 0, and the velocity is 0 at 0 and 2, which we found from part B. So we can plug that into the position functions. So plug 2 into the position function, we're going to get negative 11 thirds. Plug 0 into the position function, we're going to get 0 minus 1, which is negative 1. So we have our two positions where velocity is 0. Okay, part E, find the particle's displacement. So displacement is just forward progress from a starting point to the end point. We don't care about whether this object is changing directions or what its total distance is going to end up being, because this particle may be changing direction and backtracking between the starting and end point. But we only need to find the position at their endpoints and just compare them and look at the distance between those two values. So 0, if I plug 0 into the position, I'll get negative 1. If I plug 3 into the position, I'll get negative 1. There's no change between starting and end point, so displacement is 0. Okay, find a particle's distance from 0 to 3. Okay, so to do that, we need to identify, is there any change in direction for this particle? So this particle does have a change in direction at 2. So that means he's moving in one direction. He stops at 2, and then he backtracks in the other direction. So we need to find the distance between his starting point and his stopping point so that we can then total up his stopping point to his next ending point. So we want to find the distance between change in position between 0 and 2 seconds, and then also separately the change in position from 2 to 3 seconds. So at 0, he's at negative 1. At time t equals 2, he's at position negative 11 thirds. From time 3, he's at position negative 1. So we compare the distance between negative 1 and negative 11 thirds. He's going to move backwards, a total distance of 8 thirds. And then he's going to turn around and go forwards again. So now the distance between negative 11 thirds and negative 1 is also 8 thirds. So his total distance, even though his displacement is 0, his total distance is 8 thirds plus 8 thirds, which is 16 thirds. Okay. Part G is the velocity increasing or decreasing at t equals 2. So this is also asking about acceleration. So it's asking, is acceleration the positive or negative? So we plug 2 into the acceleration function. So acceleration function is just going to be 4t minus 4. So we plug 2 in. We get a minus 4, which is 4. That's a positive value. So since acceleration at 2 is positive, we know velocity is increasing at t equals 2. Okay, find the velocity in position when acceleration is 0. So we simply find out when the acceleration is 0, and acceleration is 0 is going to be at 1. We just set acceleration function equal to 0, solve for t. We get t equals 1, and we simply plug those back into their respective velocity and position functions, and we're going to get negative 2 and negative 7 thirds.